Hello everyone, welcome to In 5 Minutes. In this video we are going to see type 3B of linear differential equation. So in type 3A we saw that the equation is linear in y. P and Q are functions of x or they are a constant. But in type 3B our equation will be linear in x, that is instead of dy here will be dx, and instead of dx here will be dy, plus P and Q will have the same position, but instead of y here we will have x, and here P and Q are functions of y or constant. So basically these two equations are exactly similar. Here we have dy by dx, here we have dx by dy. P into y, P into x, here we have q, here also we have q, but P and Q here are functions of x, but P and Q here are functions of y. In this the integrating factor is given by e raised to integration of p. Here we have integrating factor as e raised to integration of p dx. Here we have integration of p into dy. So basically in this equation you replace dx by dy and x by y and y by x. If you replace all this, we will get these equations. It's basically the shortcut if you want to remember. Okay, so the integrating factor is this, and the solution is given by x into integrating factor. So here we used to have y into integrating factor, so we are going to replace y by x, and integrating factor integration of q into integrating factor. Here also we have q into integrating factor. Here we used to have dx plus c, here we will have dy plus c. So this is the comparison between the type 3 and type 3b type of problem. This is a linear equation in y, this is the linear equation in x. So the solution is x into integrating factor equal to integration of q into integrating factor into dy. Here it is dy, here it is dx. So now we are going to see the problem on this type. So the question is this: if we rearrange this term, like if I divide this equation throughout by dy, so I will get dx upon dy plus x. This dy upon dy will get cancelled, so this will remain x equal to e raised to minus y sec square y into dy will get cancelled. So this equation is of the form dx upon dy plus p into x equal to q. So if we compare these two equations, we will get p equal to 1. Here the coefficient of x is 1, and q we get as e raised to minus y sec square y. Then the integrating factor is given by e raised to integration of 1 into dy. It is p into dy, so p is 1 into dy, which is equal to e raised to y. And the solution of this equation is given by x into integrating factor equal to integration of q into integrating factor into dy, because here it is x, here will be dy, plus some constant. What is q? Q is e raised to minus y sec square y. And what is integrating factor? Integrating factor is e raised to y dy plus c. E raised to minus y and e raised to plus y will be equal to e raised to 0, which is 1. So here we remained only with integration of sec square y dy plus c. What is integration of sec square y? Integration of sec square y we all know is nothing but tan y plus c, and this remain as it is, that is x into e raised to y. So this is how we solve the problem on type 3b linear differential equation. So more such types we will see in our next video, so stay tuned for our future lectures.